Hey guys, welcome back to my YouTube channel. Before you watching this video, don't forget to like, comment and subscribe, okay? My name is Fikra Latodjo. On this video we'll learn about graph coloring problem and chromatic number of graph. Happy studying. Excuse me, Mr. Joe, may I bother you for a minute?
Fikra. Of course. Come in. What is it?
Would you like to help me, mister? I want to know more about graph.
Of course. So, what do you know about graph?
Got a little bit. I know graph is an assemblage of objects named point and knot or angle connected by way of a line or side.
Okay, let me be clear. Graphs are the basic subject studied by graph theory. The word graph was first used in this sense by James Joseph Sylvester in 1878. So, in mathematics, and more specifically in graph theory, a graph is a structure amounting to a set of objects in which some pairs of the objects are in some sense related. The objects correspond to mathematical abstractions called vertices, also called nodes or points, and each of the related pairs of vertices is called an edge, also called link or line. Typically, a graph is depicted in diagrammatic form as a set of dots or circles for the vertices, joined by lines or curves for the edges. Graphs are one of the objects of study in discrete mathematics. The edges may be directed or undirected. For example, if the vertices represent people at a party, and there is an edge between two people if they shake hands, then this graph is undirected because any person A can shake hands with a person B only if B also shakes hands with A. In contrast, if any edge from a person A to a person B corresponds to A owes money to B, then this graph is directed, because owing money is not necessarily reciprocated. The former type of graph is called an undirected graph while the latter type of graph is called a directed graph. I guess that's enough.
Okay, thank you very much, mister. Hey, Mr. Joe.
Oh, hello Fikra. Is there a question again?
Yes, mister, sorry for bother you again. I want to ask again about coloring problem and chromatic number of graph.
Okay, so graph coloring is a process of assigning colors to the vertices of a graph such that no two adjacent vertices of it are assigned the same color. Graph coloring is also called as vertex coloring. It ensures that there exists no edge in the graph whose end vertices are colored with the same color. Such a graph is called as a properly colored graph. The following graph is an example of a properly colored graph. In this graph, 1. No two adjacent vertices are colored with the same color. 2. Therefore, it is a properly colored graph. Some important applications of graph coloring are as follows: map coloring, scheduling the tasks, preparing timetable, assignment, conflict resolution, and Sudoku. Okay, next, chromatic number. Chromatic number is the minimum number of colors required to properly color any graph. Chromatic number is the minimum number of colors required to color any graph such that no two adjacent vertices of it are assigned the same color. In this graph, 1. No two adjacent vertices are colored with the same color. 2. Minimum number of colors required to properly color the vertices equals 3. 3. Therefore, chromatic number of this graph equals 3. 4. We cannot properly color this graph with less than 3 colors. A simple graph of n vertices n greater than equals 3 and n edges forming a cycle of length n is called as a cycle graph. In a cycle graph, all the vertices are a degree 2. A planar graph is a graph that can be drawn in a plane such that none of its edges cross each other. All the above cycle graphs are also planar graphs. Chromatic number of each graph is less than or equal to 4. A complete graph is a graph in which every two distinct vertices are joined by exactly one edge. In a complete graph, each vertex is connected with every other vertex. So to properly it, as many different colors are needed as there are number of vertices in the given graph. A bipartite graph consists of two sets of vertices x and y. The edges only join vertices in x to vertices in y, not vertices within a set. A tree is a special type of connected graph in which there are no circuits. Every tree is a bipartite graph. So, chromatic number of a tree with any number of vertices equals 2. Can you understand, Fikra?
Oh, thank you so much, mister. I can finally understand it all about coloring problem and chromatic number of graph.
You're welcome, don't be tired of studying here.
Thank you for watching, guys.